Okay, guys, what should we talk about? गपशप लिखा है? I don't know. करेंगे गपशप तो गपशप ही करेंगे, हाँ? लेकिन तुम लोग ब्लैक होल आए हो तो हमें बात शुरू करनी चाहिए ब्लैक होल्स के साथ. I know that's the logical way to begin, because if you're here at the black hole, you've got to know what black holes are. Okay, but before we talk about black holes, we got to talk about where they came from and what they are. So, if you go out at night, you look at the sky, you'll see stars and stars and stars. Now, if you try to connect those stars up with a line, you get something like that. Do you see over there? You'll see different constellations. You'll see, they've been given different names. One has been called Orion. One has been called Big Bear. Anybody else?
Big Dipper.
The Big Dipper.
Small Dipper.
Small Dipper भी है, होगा, हाँ. Okay. क्या? The Milky Way. No. Milky Way is not a constellation. See, the Milky Way is a galaxy. A galaxy is lots and lots of stars, and most of the stars that we can see belong to our galaxy, to the Milky Way.
Did you say Milky Way?
हाँ.
I know something about that.
Yeah, tell me.
Your Andromeda will also crash into our galaxy.
एक मिनट इसको या जो बोले ना उसको माइक तो हाँ. But this is really an interesting question that you've asked. ठहरो यार, ठहरो. We need, this is important. This is important. हाँ, अब बताओ. मुंह नजदीक रख के बोलो, हाँ यार, माइक मुंह के नजदीक रख के बोलो.
इससे?
हाँ, आवाज जोर से आएगी फिर. हाँ. Okay, good.
Milky Way and the Andromeda will crash into each other in 5 million years.
लेकिन why is it the Milky Way?
Huh?
Why is it called the Milky Way? What is milk? Milk. दूध होता है ना, हाँ. अच्छा. So why is it called the Milky Way? Huh?
No.
Yeah. What did you say?
He was saying it.
अच्छा.
He was saying because of its color.
हाँ.
What?
Why?
I think it's called the Milky Way because it looks like as if we splashed milk across it, since there's so many stars and it's just like a splash of milk.
Beautiful. That's exactly the way. That's exactly the reason.
One more thing.
Bolo.
In the center of the Milky Way, there's a giant black hole. No, a little small black hole which is called Sagittarius A.
There is actually a giant black hole. You're right. I don't think it's called Sagittarius. No, that is Sagittarius is what?
Sagittarius A star. It's called Sagittarius A. So he's right.
He's right.
Right. Yeah. It's called Sagittarius A star because it's located in the constellation of Sagittarius, and it's the brightest object in its group. So that's why it's called A star.
Yeah. Okay. It's not a. वो मैंने बताया, हाँ मैंने बताया, yeah. So these are so many different constellations. The point is that you look at the sky and you will see so many stars. Now, how old are you? 5, 10 years old, 15 years old, 20 years old? No, nobody's 20 years old. Some are a bit older, like me. I'm a little bit older. But when my father looked at the stars, they were just like what I saw today or last night. And if my grandfather and my grandfather's grandfather and his grandfather's 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 grandfather, if they looked at the stars, they would see just the stars that we see today. So the stars seem to be there forever. And stars never seem to go away. But they do.
They explode.
Oh,
And new stars born.
yes.
Every
Ah.
second that about 1 billion stars. When like a big star explodes, it's
Yeah, इधर लगे रहो ना इधर ना. Yeah.
With this thing.
Yes.
When a
You are
big,
Kavita.
Yeah.
Yeah.
when a big star explodes, then it'll turn into a black hole.
Ah, that is actually very interesting. Yes. And where did you learn that?
I watched a video
Uh-huh.
which was for like children and it was
थोड़ा
about
नजदीक करके
stars.
बोलो. हाँ.
I watched a video that was teaching children about stars.
Oh, that's lovely. So now that we've talked about stars being there forever, Kavita is telling us that they're not there forever, that sometimes they explode. And so the question is, why do they explode? What is it that makes a star go away, but not just go away, but go away with a big bang? And so we have somebody here, and isko do.
The star's fuel run out, so it starts using its own matter, and then when it gets too much matter, it starts to explode.
Okay.
And that explosion is called a supernova.
Wow. Have you done your PhD already? No. A master's? No? Okay. All right.
Stars also fade. Stars also fade away because small stars don't explode. Actually, they just use up all their fuel, become a red giant, and then turn into a white dwarf, which will stay there for a long time. Then it will fade away.
Okay. Have you thought of applying for the position of professor of astronomy? Okay. Yes.
Also notice about white holes.
Acha. Now, look, we need to take everybody along before we talk about white holes. Yeah. So.
No. Sometimes the stars have to take mass from the sun's light, and as they go farther from the sun, they'll collect less light.
Okay.
And that's
Now this needs
what makes them. They just keep getting bigger and need more mass from the sun.
Okay.
And if they use their own mass, they'll explode into some of the biggest black holes on Earth.
Okay. Okay. So now we've agreed. We've all agreed on one thing, that stars finally do go away. Okay. Now every star is bright. It lets out a huge amount of light and heat and radiation. Radiation you can't see with your eyes, but we can measure with our instruments. And so the question is, where does all this come from? And it comes from fuel.
What instrument is used?
To see the radiation, okay, then you can use X-ray telescopes, you can use gamma ray telescopes, you can look at cosmic rays, all these different kinds of radiations that come from outer space, we can look at with different instruments. Okay, so the question is, what is this fuel that the stars burn? See, fuel is needed for everything. When like cars, absolutely. Bikes also. And
Too.
क्या कहा?
And lights too.
And light.
Yes.
No. We were asking, in these stars, there is fuel.
Yes.
And he said
Yes,
that,
I
well,
know.
cars need fuel too. What else needs fuel? Humans, absolutely. Did you all have breakfast today?
But
What did you eat? What did you eat? What did you eat? What did you eat? नाश्ता क्या किया? Peanut butter. अच्छा. रोटी के साथ खाया कि नहीं? डबल रोटी के साथ खाया या खाली peanut butter खाया? अच्छा. Now you see, peanut butter is good fuel. Why is it good? Because you eat it and your body then gets energy from it. And if you don't get peanut butter, then you get something else. But if you don't get something else, then what happens? You die. Nobody wants to die. So you need fuel all the time. Stars need fuel all the time. And do you know how much fuel? Okay, a lot of fuel. But does anyone have any idea of how much fuel our sun consumes every 1 second? How much peanut butter does... Now, the sun doesn't eat peanut butter. What does it eat?
Can we talk about the peanut butter? It eats light.
Yeah, but look, he eats peanut butter. The sun eats something else. What does the sun eat? Hydrogen. The sun eats hydrogen. And how much hydrogen does it eat in 1 second? You probably don't know. I'll let you know. 600,000 tons of hydrogen every second.
actually, the last number is 2.
Hello. Come quickly. Where's your brother? Oh, they're all here. Come here. Come. Huh. Yes. So, 600,000 tons of hydrogen every second is not small. What is this telling you? Bolo.
And white, I almost forgot to tell you, white holes also form to a black hole.
Okay, but we'll come to that later. You want to say something? Then he wants to say.
There are many different types of ways fuel is used: fusion, combustion, and nuclear reactions, and also
Acha.
chemical reactions.
So, when he eats peanut butter, what kind of reaction is that?
Chemical reaction.
Chemical reaction, but he doesn't look like a chemical to me.
But biology uses chemistry.
Okay, so this is very important. You see, this young man over here, he eats peanut butter every day for nashta, and there are chemicals inside him, there are enzymes inside, there are things that convert peanut butter into energy. But as Adarish told us, there's also a different kind of reaction. There's a different way of using matter to get energy, and that is nuclear reactions.
And fusion.
Now, nuclear reactions generate a huge amount of energy. So much energy that, if just this much, see how much this much is? This much hydrogen is completely converted into energy. Then Einstein told us E equals mc squared. So this much matter is enough to light all of Islamabad, all of Pakistan, and the entire world for a whole day. So much energy is released when a nuclear reaction happens. And now you can just imagine that if the sun is eating up 600,000 tons of hydrogen every second, how much energy it must be releasing. Can you imagine it? I can't. So, what do scientists do when they can't imagine something as huge as that? Then? No, they use numbers, which.
They do calculations.
Calculations, but then, yeah.
Can they use something to compare it with? Like to imagine how much energy the sun has, we could say how many Earths that energy would be in size.
That's an excellent idea, actually. You compare against something, right? Then there's also a way of making that comparison easier. You use words like 1,000, million, billion, trillion. What's after trillion? I don't know. But then you run out of words. No. Then, can you write down 10? Then you write down powers of 10. You use what is 10? 10 into 10? 100, right? So you write 10 power 2. Then what's the next after you multiply by 10? What do you get when you multiply 100 by 10? 1,000. That's 10 to the power 3. What's 10,000? 10 to the power 4. What's 100,000? 10 to the power 5, etc., etc. A million is 10 to the power 6. So every number can be put in powers of 10. And that's the lovely thing. Then you are freed from your. You see, my mind is too small. Your mind is too small to understand all these big numbers. So we use 10 to the power this, that. And we can never run out of that. Yeah.
10, 10 to the power of 100 is a Google.
10 to the power 100 is Google. Okay. All right. Is it?
Yes.
Okay. Okay. So, what's 10 to the power Google? That's a still bigger number. And so, there's no limit to this. This is the beautiful thing about mathematics. Because we can't imagine it, but we can write it. So number, no matter how big, we can always say, oh, it is 10 to the power Google, to the Google, to the Google, to Google. We can, okay? Now, the sun has got a huge amount of hydrogen. It's so massive that you can put in more than 1 million Earths. The moon is so moon is चांद जो है मक्खी के बराबर है. It's only 1/7 of the mass of the Earth. much so. Huh? So it's small. Now, if the sun is so big, how is it that it can run out of fuel? It's got so much fuel.
The sun uses fusion reaction, which merges matter to they merge the hydrogen atoms together, which releases a lot of energy. But it also creates helium, and helium is a bad fuel. It doesn't run very well.
Okay, correct. However, that doesn't take away from my question. Why is it that the sun, which is which is a million times heavier than the earth, how can that run out of fuel? It's got so much in it. The reason is that, okay, it's big, but it's also using up energy it's using up energy. So eventually it is going to run out of fuel. By the way, do you know how long the sun has been around? You know, we look at the sun and we say, oh, it's there, and it was there yesterday, and it was there the day before, and every day before that. But was there a day that if you had woken up, you would not have seen the sun? No. Yeah.
Sir, did you know that the sun was made from a really big storm cloud
Okay.
years ago?
So answer my question. How long ago had you woken up? So if you had woken up a certain time ago, you would not have seen the sun. Do you have any idea of how long that long ago is?
No.
The sun is not that old. Some of the water we drink is older than the sun.
I'm not sure. Yeah, that's a complicated question because it's a question of whether water existed in the universe or not far back. But my question, and look, don't bring in new pieces of knowledge, answer my question if you know the answer. If you don't, I'll tell you what the answer is. It's about 4.5 billion years ago.
It's the life of Earth, I think.
The Earth came after the Sun, obviously, but so 4.5 billion years ago, and yeah, you have to say something. You want to say something? Yaar, usko do.
The solar system was created from a explosion of the supernova. So it could be possible that the sun and earth was created at a similar time.
That's correct. That's absolutely correct. So roughly speaking, the sun. Wait, when somebody is speaking, you should listen. Yes. So you're correct that the sun and the earth came at approximately the same time, and that approximate time is 4.5 billion years ago. And what is a billion? See, we talked about how to write a big number. How much is a billion, anyone? It is 10 to the power 9. So remember, 1 billion is 1,000 million. Yeah. Now you can say, yeah. Give it.
Now can we talk about Earth?
Huh?
Now can we talk about Earth?
Well, we will talk about the earth. Huh? Huh?
Isn't it 100 million?
What is?
In 1 billion, isn't there are 100 million?
1,000 million is 1 billion. Yeah. So, a few things we have to remember. 1,000 is 10 to the power 3. A million is 10 to the power 6. A billion is 10 to the power 9. Yeah. And we were just told that a Google is 10 to the power 100. Okay, so eventually the sun is going to run out of fuel no matter how big it is. And then comes a problem. What is the sun going to do? So, you see, the sun has been using up the hydrogen and it's been producing another element called helium. Now, helium is also a kind of fuel. It's not such a good fuel, but it's something that, so you see, if you don't get peanut butter, then you can, of course, eat cornflakes. Cornflakes? No? क्या खाओगे? चने खाओगे? हाँ, तो अगर पीनट बटर नहीं मिला तो सुबह उसको चने मिलेंगे. तो ऐसे ही ना, हाँ. तो जब चने भी खत्म हो जाएंगे फिर क्या मिलेगा? दाल. अच्छा, दाल के बाद क्या? अच्छा चलो फ्रूट. फ्रूट के बाद क्या? नहीं, उसके बाद तुम्हें भूसा मिलेगा. भूसा? अरे भूसा किसी को पता भूसा क्या होता? जो गाय को खिलाते. बिल्कुल. हाँ. You do need it, yes. People have to hear you, yeah.
Okay. Did you know under earth there's gold and under mountains there diamond?
Yes, you are right about that, but it is not relevant to what we are talking about. So, the sun first eats up the helium, then it generates carbon, then it generates this, that. But ultimately, it's got nothing to eat. And so then our sun is going to get sick. And you know, when our sun gets sick, what will happen? It'll develop. Shh, don't talk out of line. It'll develop a temperature. It'll get red in the face. Okay, so can you do that? Well, how far can you do this? That's good. But the sun is going to get a face that's going to get bigger, and it's not going to explode, but it's going to become a red giant.
No, I think it's going to be a white one.
A red giant will be what our sun will become. And you know, it'll become so big, its cheeks will become so big that is going to swallow you up. Yes.
Yeah, the sun will expand so much that it's going to absorb the planets.
Yes, that's what I mean. That's exactly he's absolutely right. The sun is going to get so big that is going to eat up the planets. And so it's going to have you for lunch. Yes. Okay. Batao.
Did scientists did scientists really know that this will happen? Or they're still researching that it will happen?
You know, his question is good. How have we seen this happen? Is that it?
No. Do they know this will happen, or they're still researching that it will happen?
Listen to his question is good. And I'm just going to put it in a different way. You are asking me, do we know for sure that this will happen?
Yes.
Which means, have we seen this happen elsewhere?
No.
And the answer is, yes, we have. If we look at different stars and there are billions and billions of them, we see that some of them are normal and bright and happy, like you are over here. Don't keep interrupting. Don't keep interrupting. Other stars are running out of fuel, and some of them have become red giants. So, in fact, the answer to your question is yes, yes, yes. We see it happen elsewhere, and that's why we believe the science behind it. So, on the one hand, we can do calculations which tell us that a star will go through these different stages. That's one thing. But on the other hand, we can go with our telescopes and we look around and it says, that's a red giant over there. And we can see how sick it is because we can measure its temperature, just like a doctor measures the temperature. He puts a thermometer in your mouth. So my question now is, how do we know the temperature of a star?
Yeah,
Its color.
mine too.
So, where is the mic? Where is the mic? Yes. Now explain.
Some stars have many different colors. Some are red, some are yellow. Our star currently is a yellow.
Sun is white.
No, that's great.
It's kind of white and kind of yellow. It's light yellow. Some stars are blue, which are very much hotter, and then the stars that are red, they're a bit cool.
Okay, so just like a doctor takes your temperature with a thermometer. Our thermometer is the instrument with which you look at a star. The light from that star comes through and goes through a prism. It's separated. You can see how red it is or how blue it is. And in this way, we can get the temperature of a star. So a star doctor, you can say, would know the temperature of his patient. Yes.
I'm saying that some stars are sun's burst. Some stars.
What?
Sun's burst.
Some stars are
क्या कहा?
ये कह रहे हैं कि some stars are much bigger than the sun.
Yes. Go ahead. बोलो.
Did you know the sun was created and it had rings?
No.
When it was created.
Wedding rings?
It was created.
Saying that Jupiter has rings and Saturn has rings.
No, I'm not saying that. I'm
No,
saying
you are saying that sun had rings.
Don't speak unless it's in the mic.
Mike.
यार तुम्हारे हाथ में माइक है. मुंह के नजदीक करो.
Did you know?
Huh?
Did you know? First, the sun was created and it had rings. When it was created in the first time.
It can only be created once. What do you mean created the first time? It had rings, yeah. Okay. And those rings are still there. I mean, those are the planets that are going around the sun.
Yes. Almost in the side of it.
Yeah, you were saying something?
No, I just wanted to share something about a star.
ये दोस्त को.
One of our planets, Jupiter, is often called a failed star. Jupiter.
That's interesting. Yeah.
No, it's not. Jupiter. It's not the right size to become a star, but it's made out of the same thing.
But that's yeah. Tell us about that. Tell us.
some people say that Jupiter is often called a failed star, but that's not actually true because it doesn't have the correct size and amount of matter which it needs to have and burn fuel and eventually become a star. But it's gonna take like a very long time, and it doesn't have that much time, and it doesn't have those kind of materials which are needed for its growth.
Okay. This is a very interesting point. It's yeah. Do you want to say something on it that'll add to it? No, Adrish. Yeah.
Anything can actually become a star if you were big enough and you have the right elements. If you were big enough and dense enough, you could become a star too.
Yeah. So should we feel sorry for Jupiter? No. Kind of.
I mean, Jupiter doesn't have feelings.
Jupiter doesn't have feelings. How do you know? Very interesting. He's saying that Jupiter is not alive. Some people say the Earth is alive.
Yes.
Plants,
Huh.
And it has air in it.
Okay.
It also has an inner core which gives it energy and stuff.
Sir,
Yeah.
we all know in Jupiter there's a big red spot, but in Saturn there's a big white spot.
Okay. Yep.
There's another theory that Jupiter could also suck the planets around it, like absorb it.
No.
There's a rough theory.
But it's
Did you make up that theory?
No, I've seen it.
You've seen.
Like the sun, it could expand too. Some people say it.
Okay, so Jupiter is a failed star. We now have heard that. And you know the reason is because it can't get a nuclear reaction working strongly enough inside it. The sun is big enough, it's got a lot of hydrogen, and so it was able to create that. So a nuclear reaction could start in it, and so it started emitting light and heat all over. And Jupiter, unfortunately, cannot. And some people, how many people feel sorry for Jupiter? And how many feel that we shouldn't feel sympathy for it? Okay. You're very hard-hearted. Okay, yes. Okay, so the sun is a very decent star. Our sun is a very decent star. When it runs out of fuel, it's just going to get big, sicker and sicker. It'll eat you up, of course, everybody. It'll eat up the planets.
There would be more heat.
And then it's going to contract and it's becoming sailor.
It will get bigger and bigger.
You're talking too much. You're talking too much. Talk only when needed, when necessary. Okay? But there are stars which are not so well behaved as our sun. They are bigger, they have more fuel, and when they start running out of their fuel, they go, "Pah!"
But you said it is a decent star.
So those stars which explode, they are called, you told us, supernova. You called us, you know it's supernova?
Yes.
Okay. How often do you see a supernova? Not very often. Once in 300 years in our galaxy, in the Milky Way. The last one that we saw in our galaxy was in 1987. Were any of you around at that time? No. Oh, you missed it. Oh, I feel so sorry for you.
Did you see that?
Did you see her?
Did I see it? I was sleeping that.
Sir,
So I missed it. And you know what's the funny thing? There were astronomers and they were looking for gravitational waves coming out of that supernova. And they had turned off their equipment. And so they missed the one thing that happened in 300 years. And they were saying, why did we do that?
But don't supernovas last for like months or years?
Yeah, but the waves, the gravitational waves that come out, they don't last that long. They last a day, 2 days, 3 days, and they couldn't turn their equipment. They didn't have the right equipment at that time, so they missed it. And now they'll have to wait for another 300 years before it'll happen in our galaxy. Huh?
Sir?
What?
What if they miss it again? They're gonna fire
What if they miss it? I hope they don't miss it again. But hopefully. So now the equipment is more sensitive, and so you can look at other galaxies. And if there are supernova over there, and there are lots and lots of galaxies, so there are supernova which are happening a lot of the time. Yes, your question.
The most coldest planets in the universe are Neptune and Uranus.
The coldest, did you say, or the oldest?
Coldest.
Coldest. What about Pluto?
Because they're the most.
Uranus is the coldest planet.
Uranus.
अच्छा
यूरेनस उस नेपच्यून से ज्यादा है सर.
अच्छा. If you go there, you should, take a warm coat.
Sir?
It will not work.
It'll not work?
Yes.
Okay. So what will you need to wear if you go to Uranus?
Sir? You cannot survive for
Bolo?
Did you know that in Mars there is a volcano that is 10 times bigger than Mount Everest?
Acha. Okay. Yeah. Yeah. What?
Yes, yes, and it also has 3 moons. Some planets even have 1,000.
Yes, actually, I think Jupiter has more than 200. No, can't have 200 moons.
It's a very good there's a very good coincidence behind this.
By the way, what is a moon? Can anyone tell me what is? Moon is a satellite.
It's a satellite which protects us from
Yeah, but what is a moon? Yeah.
Is moon important to have to every planet have moon?
Is it important to have moons? I don't think so. I mean, I don't think.
I think yes, because moon controls oceans, seas.
Yeah, but what if you don't have an ocean like on Mars? I don't think Mars has a moon.
Mars has.
Does it have?
Yes,
I don't think so.
but it's red. I think.
Does Mars have moons?
It has 2 moons.
It has 2 moons.
but Venus and
Okay.
Even they have names.
Yeah. But what makes a moon? Should I say a little thing, a little rock going around a planet? Can I call that a moon?
it's rounded.
Anything that orbits around a planet.
But then the Earth has got 10,000 satellites going around it. Are they all moons?
No, there are 7,000.
They give internet. The moon is a natural satellite, and the others are man-made
But there are also little rocks going around the Earth. From the asteroid belt, they came over there, were captured somehow. Yeah.
They're either too small and they don't reflect light like the moon.
Okay. So the question is that of size, and if something that's going around is big enough, then you can call it a moon. Otherwise, you'll say, it's just something like that.
It's like
Yeah.
Well, I don't know if this is true, but some people say that exoplanets gave gas to Earth while it was forming, and then a ton of rock and heat came out which formed the moon, which got an actual satellite.
Sir?
Okay.
And some people say that exoplanets crashed into Earth while. Some people say that the moon was formed while an exoplanet Theia crashed into Earth while the Earth was still forming, and it caused like a big explosion, which then gave out a lot of rock and debris, which then formed the moon.
Sir?
That's actually very plausible. So what you're saying is that something slammed into the Earth, and the Earth was very fresh, very new at that time, and patak, it threw that stuff out, which then was molten, and then it got rounder and rounder, and it became the moon, and it went around the Earth, and that's how we have our moon. And okay, so I think we are pretty much close to the end. Yes, sir?
I'm saying that why do people discover more about Mars than other planets?
Oh, because it's closer. It's closer. Yeah, yeah.
We haven't even finished exploring
Mike, though. Mike.
We haven't even explored the whole Earth. Why are we exploring other planets?
Oh, come on! You've explored the Earth. Haven't you been to Karachi?
No.
And people have been to everywhere on Earth. Yeah. Okay, but we didn't even get to black holes, so we'll talk about that next time.
How is
Okay.
that fun?